I'm very happy that so many came to my session here today about integration testing with Docker and Testcontainers. And so a little bit about myself before we begin. My name is Kevin Wittek. I work as a software engineer for the German software company, consulting company CodeCentric. And I'm also doing a little bit of consultancy with my own company, like trainings, workshops, and so on. And I'm one of the maintainers of the Testcontainers project, so therefore I hope I'm a good fit to talk to you about this project here. And in general, I'm a big open source, free and open source software enthusiast. And yeah, we have some flashing lights here, that's like effects. And I'm an Oracle Groundbreaker ambassador, so maybe you've seen some others of us here around. And in addition, I'm also one of the organizers of the local software craftsmanship meetup in my hometown, home area, Ruhrgebiet. So, like when I was thinking about going to Rome, what came into my mind was actually something like this. So, I don't know, maybe some of you recognize the screenshot. It's from a bit older computer game called Caesar 3. But then when I arrived in Rome, I found out maybe Rome looks more like this. And yeah, it's not the best quality picture. But what I like about this picture is that we have this like historic buildings, maybe monolithic buildings, and then we have some containers in front of it. So. And since we will talk today about containers and everything nowadays is about containers, I thought it would be a good start into the talk. So what I want to show you in this talk and want to present to you, like the learnings I want you to get out of the session with, is that if we use the tools at hand we have nowadays, it's quite easy to set up a complete test environment, development environment, described in code, set up by executing code. And this, on the other hand, means it might be possible for our projects to use and write integration tests without a lot of effort. Like we can have an effortless way to write integration tests against real external applications. And probably we will skip the last part, the development history of the Docker Spock extension. We will focus more on the actual test container stuff. And like the 3 lines at the bottom, that's what I think about a successful onboarding experience in a project. In an open source project or in an enterprise project. I want a new developer to be able to come into a team, into a project, clone the repository, run a Gradle build or Maven build, and it should like just work. It should run the build, of course. It should also run the unit tests, and it should also run the integration tests. So I don't want people having to follow big instructions in some Wikipedia about you have to set up this test database, you have to configure this system on your local system and whatsoever. Everything should be part and self-contained into our repository, and I think it's possible if we use the tools at hand in the correct fashion. So, since we will talk about testing, let's go a bit into the theoretic stuff about testing, about what is integration testing, what is unit testing. So most of you will probably know this classical testing pyramid, either from, I don't know, university or literature or whatever. And we have this very big base of automated unit tests, and then we have this not so big but still big amount of integration tests. Here we have like multiple different names for those, which I like, but in general we call the middle layer simply integration tests. But sometimes they have a different name. They are called component tests, black box tests, system tests, whatever. But let's just call them in this talk now integration tests. And then we have at the top we have some automated UI tests or GUI tests. And sometimes these are called end-to-end tests, sometimes these are called functional tests or even acceptance tests. That also depends from project to project, from team to team. And in the ideal world, like on top of the pyramid, there is a role of the tester, of the quality assurance department, and they do like manual session-based explorative testing and try to find creative stuff that a computer, that an automated test can't find. So, what's my definition for today for the talk for what an integration test is? I would say an integration test is every test that interacts with external systems or external dependencies. And examples are a test that will need to launch an application server or an application context. Like, for example, in Spring, we would have a Spring Boot test annotation. This would boot up the Spring context. This is something I would consider an integration test. Also, it's kind of slow and it involves a lot of moving parts. Of course, in the JEE world, everything involving like a JEE application server or even an embedded one like Thorntail or something with Aquilion, that's, in my opinion, definitely integration tests. And like even testing against external frameworks or like integration against the framework or libraries, I would say it's an integration test. Like we're testing integration against code that's not under our control. But of course, the classic thing that always comes to mind are tests that interact with real external systems, external ports, and that's stuff like a file system or a database or other APIs, REST APIs, HTTP services, whatsoever. And the stuff I'm going to show, like with Testcontainers and Docker, of course, it's like very well suited to the last part of integration tests, like when we have to test against our external dependencies. So, I was thinking, like, why do we have this pyramid? There are, of course, valid historic reasons, and there's a historic context for the way the pyramid is shaped. And most of them have also to do with computational resources or hardware resources back then when this kind of pyramid was invented. And I was thinking, like, how would we shape this pyramid if our machines or our tools would be fast enough so that integration tests are nearly as fast as unit tests? Would we still have a pyramid or would it look differently? And there are actually nowadays some companies thinking about it. I'm not saying like the classic test pyramid is a bad way, but I think it's worth rethinking about it and thinking about if this pyramid applies for our projects. And there was a very nice blog post from Spotify about how they structure their test suite for testing their microservices. And they said they have this testing Honeycomb. There is a similar presentation from Logs.io, which is a software as a service logs company, and they call it testing Diamond. But yeah, there is like a new way of thinking from some new developers. And they say like, okay, now the bottom part, it's called here implementation detail, but it's actually the unit test. Then we have a big layer of the integration test, like the meat of the test suite at Spotify would be integration tests. And then we have some integrated tests, and those integrated tests are an anti-pattern. We don't want to have them, but a question like, what is an integrated test? Does someone know the term integrated test? Yeah, so I didn't know about this term either before reading the blog post, but it's very well exploring this term when thinking about the test suite, and we will look into this in a bit. And a little bit of reasoning why Spotify said they have this kind of testing pyramid. They say like they write very small microservices, they have a small core of business logic in there, but they have a lot of integration surface to other systems, to other services, and so on. And they say since they have basically more integration code than actual business code, it makes sense for them to have kind of black boxy or more black boxy integration tests. So they don't want to mock or stop stuff in the tests because they want to have the ability to do extreme refactorings of the service. And the black boxy integration tests will still work even if they rewrite big parts of the integration surface of their microservices. So that's why they say they use integration tests, and they use, for example, also Testcontainers for those integration tests. And we will come to Testcontainers in a bit. So, but like before we go further into the technical details, I want to have one more thing defined because I think it's really valuable to think about tests in this way. And this integrated test thingy. In the Spotify blog post, there was a link to the definition, and the definition was probably originally from J.B. Rainsberger, who is a more prominent figure in the TDD and software craftsmanship community. And he said an integrated test is defined as follows. I use the term integrated test to mean any test whose result, pass or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior, which we can compress the way Spotify described it, a test that will pass or fail based on the correctness of another system. So integrated tests are an anti-pattern in our test suite. And what are concrete examples for integrated tests? In case we have to manually spin up other services, for example, locally in our test and build environment to make the test pass. So simply, if we have to have a running instance of a database or whatever, be there installed and running before I run my integration test locally, this is something we would call an integrated test, because the same test suite execution would pass or fail dependent on if I have installed this dependency or if I maybe like stop the service or whatever, stop the process. So that's one example. And another very prominent example is if we are testing against shared services in a shared environment. For example, we have one big integration test database and all the teams use it, and maybe even using the same schema like as part of their CI build, CI testing. And one team might change something in those databases in the schema by testing some migrations or whatever, and the test of another team will fail. And yeah, that's like really an anti-pattern. We don't want to have something like this. But also like changes to your system break test for other systems. For example, let's think about microservices. You're constantly deploying your microservices with the latest version into a shared environment where the integration test or system tests are run, and then you are updating your version of your microservices with a new version, maybe changing the API, basically breaking your API, and then suddenly the tests of the other teams of the other microservices might break because you push an update and it was directly there. And yeah, those tests we don't want to have because like they make the actual output of the test suite very confusing, and we can never really trust our CI or our pipelines, and they are kind of non-reproducible also then. And yeah, so we want to avoid them, and we will use Docker and test containers to avoid these. Yeah, so which tools to use? Like we want to integrate all the stuff, thinking about Docker and so on, just integrate it with our normal Java tools. So I just put some stuff here, but you can use whatever Java tools you want, basically, from the mindset. So the important thing here is that we don't try to solve these problems with non-JVM ways. Like we could also employ a lot of bash scripts or whatever to do this Docker stuff, but we want to stay focused in the JVM and like close to our actual tests. Yeah, and so one prime thing we will use to make this possible, to spin up these external dependencies we need, this will be Docker. And is here someone who doesn't know about Docker? Yeah. Okay, yeah, so but containers, you know about containers, or yes, yeah? No, I was looking to a guy over there. So yeah, like let's just say this like containers, Docker containers is like a virtual machine. Although this metaphor, this comparison is not too good because it's not like a virtual machine. But for the way we can interact with it, let's just think about it like a virtual machine that's super lightweight. So in practice, like the technical implementation is very different from a virtual machine, since you can see a container, all the containers are sharing the same kernel of the host operating system, but it's basically a way to run application or processes in a kind of isolated fashion regarding their file system. And since it's very lightweight, we can very easily start containers, remove containers without a lot of overhead. And we just want to use this, leverage this capability of Docker to quickly spin up our external dependencies like databases, like other servers, test against them, and then throw them away directly on our local machine, on CI, wherever, always the same, instead of spinning up virtual machines, which is more expensive. Yeah, so why now we want to combine this Docker stuff, these containers, with our Java tests? Yeah, because we try to achieve a very easy self-describing setup of a development environment. And I'm saying here development environment because for me, I'm very much into TDD, and I think you can also use a TDD-like approach with integration tests. So local testing on my machine is part of my development experience. And we also want this build and test environment to be uniform over all of our environments. So I want to know if it works locally on my machine, it should also work on the CI. So it should use the same mechanisms to bootstrap and set up the environment it's running in. And yeah, since we don't want to have integrated tests, we don't want to install any or configure any external software. But of course, we will need Java and Docker, but yeah, that's what we have to live with. And this is something, the goal we want to reach. New developer comes into a team, clones the project, runs the build, and everything runs, including integration tests, including everything. Okay, so how to fuse like the Docker world with our JVM, JUnit world. And here, Testcontainers comes into play. And yeah, some of you might have seen a similar looking cube to in the morning in the intro presentation of the Oracle keynote. It's not related to each other as far as I know, and I think we were first with the Testcontainers logo here, but yeah. So that's Testcontainers. Testcontainers is an open source Java library for instrumenting Docker containers with the main use case of using those containers as part of your tests. And that's how you would use it. You would, so that's like the basic API. You can define a container object. You can say like it's based on this certain image, like here it's a Redis. You say, I want to interact with these ports of the container, and then you can just run start, and then you can do your stuff, then you can run stop, and test container will clean up everything. So that's if you would want to manually interact with test containers. And there's already some interesting stuff that's going on just in this example. So the start command, for example, is a blocking command. Means it's not just creating the container and then returning. Like, for example, if I would, I'm just opening a terminal here. If I say docker run te, let's do it like this, docker run Postgres, should be like this. Okay, so this command basically returns directly. So we directly created a container that represents a Postgres database, but the problem is, at the moment this container is created, this doesn't mean that the application inside the container is already running, is already in a state in which we can interact with it. So if we then look what's actually happening after the create has been issued, so we see there is a lot of stuff going on actually until the container really starts. It's like bootstrapping its schema, it's creating internal database like tables and everything, and it takes nearly a couple of seconds until we can actually interact with the database and with the application inside the container. And since this is a generic problem for all applications in a container, Testcontainers provides a way to solve this problem, this race condition you're having basically, and it will wait. So the start call will wait until the application inside the container is ready. Of course, readiness can mean different things for different containers, for different applications, but the most naive default implementation will just wait that this port, this defined exposed port will accept TCP connections. So that's like the most simple use case, and for very simple containers and applications, it already works. For Redis, for example, this will work sufficiently. For the more complex applications, there are more complex waiting strategies that can be used with test containers. For example, for a database, you can wait until it accepts a JDBC connection, or until you can issue a certain SQL command on the database that will return a certain output. Or in case of a HTTP service, you can like expect a HTTP endpoint to return a certain response. So it's quite flexible in this way. Or for like really legacy containers or like bad implemented containers, you can also just check that there has been a certain output in the log messages of the container. in case of the Postgres container, it's even what Testcontainers does because it has some quirks. Yeah, so this is this thing. And in addition, like with exposed ports, what's happening here, it's the same as saying in case of the Postgres here, I will just remove the container. Okay, so it's the same then saying minus P. So basically what it says, publish this port for the container. Okay. And then what will happen? The Docker daemon will automatically bind these ports it should publish to an ephemeral port on the host. So like the ephemeral Unix ports, that like very high ports that are free or like can be used for such stuff. Like it will automatically bind for a free port. And why do we do this? So we could instead just say, okay, bind this port to 5432 every time, and then we know how to connect. We don't want to do this because then by definition we would directly have an integrated test, because this test would fail if the port is already used by whatever reasons, because we're running tests in parallel, because we're running other stuff. We really want to just like let Docker decide on which port to publish. And since we don't know the port now, like we only know the port after the start, we have additional APIs and test containers to get the actual map port after it has been started, and then you just inject them into your test system and you can use it. All right. So yeah, there is a lot of different features already built into test containers, like support for generic containers, where you basically provide just the name of an image, and you can then use it. Like you can also use your own images in this case. If you're already using Docker for your CI stuff, or even in production, just use your own Docker image from your own registry to spin up the container. And there's also support for some specialized containers. We will see in a bit in a demo that have like additional convenient functions, like databases where we have some convenient APIs directly available, like more convenient wait strategies already set up. There is support to instantiate containers based on Docker files or Docker DSL. Also support for instantiating a multitude of containers based on a Docker Compose file. Here, this I talked about, the dynamic port binding, that it will automatically bind to free ports, the wait strategies I talked about. And it's very cross-platform, like we try our best to work on most operating systems, which is basically at the moment Linux, OS X, and Windows 10. And we see like normal Docker installations, which means Docker for Windows, Docker for Mac. On Linux, of course, the normal Docker installation. But Testcontainers also like tries to really work out of the box. So we have a kind of an environment discovery built in, meaning it will look like which kind of Docker you have installed and configure itself automatically to work. All right, yes, works on Windows 2 since a bit. And yes, JDK 12 compatible, and we regularly build it in Travis against OpenJDK early access, but I think now against 13 it's failing, I'm not sure. So this is some stuff of built-in modules, like support for built-in containers, all kind of databases, also Oracle database, and like Oracle Express Edition, and NoSQL databases like Cassandra, but also very different stuff like Apache Kafka, and which is a really cool feature like support for browser and Selenium testing there. All right, here are some of the users. We have some very prominent users nowadays, like for example, Spring Data is using it internally a lot for integration testing of Spring Data, but also companies like JetBrains use test containers for testing parts of TeamCity actually. All right. I've shown you like the vanilla API of test containers, but there's also other ways to use it. Like with JUnit 4, there's a JUnit 4 integration. You can just define JUnit rules or use JUnit rules to automatically start and stop containers. Like you can say add class rule or add rule, and then test containers will automatically start the container before the test or before the test class and tear them down afterwards. a very similar integration with Spock, which is a Groovy testing framework where you just annotate your test class with test containers. And since some time now, we also have support for JUnit 5, JUnit 5 extensions. So you can just annotate your class with test containers, and then you can annotate the fields with container, and then the extension will automatically manage the life cycle of the containers. And it also works very well with nested tests in JUnit 5 case. Okay, but finally I can show you a real demo. All right. Cool. So, like how you integrate it now in your project. Basically, all you have to do is add the dependencies, the Maven dependency, and then you're good to go. Of course, you need to have Docker installed. Like this is Gradle now. Just integrate this, and then we have like different modules available, depending on what you want. And of course, on Maven it would be similar. And let's look at our example. It's a super stupid example, like we have a bookshop, not even a bookshop. We just have a book class we can save in a database, and we have a book repository. And nothing fancy here, no JPA, nothing, just like plain Java connection class, plain JDBC stuff. Just a repository for saving books, counting books, and so on. Just SQL stuff here, nothing special. Now we want to look at the test. And now we see here we're using the JUnit 4 integration, so we annotated with @rule. We have here a special container, PostgreSQL container, and that already has some of the convenient stuff. I will just run the test for now. Like the test method, super simple. It checks like empty repository is empty. After saving, there's one book in there. All right, and like you can search for books. So the tests are not the interesting part here, but we are basically seeing, okay, the tests are running. And all the time it was like showing small Docker icon here. So all the time it was starting and stopping a Postgres database here. All right, and here we see some of the convenient stuff that's in these special containers, like Postgres container, or basically all JDBC containers have this get JDBC URL, and you can directly use it. And then you get like the JDBC URL for connecting to this container. And here we're doing so one thing to keep in mind when using something like test containers, you don't know, like you can't access these services like statically. So you only after starting you know the actual port it's running on. So you have to find a way to inject this configuration into your system under test. And if you're not using any frameworks, it's very simple. Just use something like dependency injection, manual dependency injection. Like here we are instantiating our book repository, and we're just like providing the JDBC URL as a constructor parameter. And you can have similar approaches. So if you're really like going on like this with your own classes, it's super easy. But if you have using existing framework, especially JE stuff or whatever, it might get more difficult. You have to work around with system properties or whatsoever, but that really depends on the framework. You basically have to make sure that you inject those configuration, like the data source URL, before your system context boots up. But we have like a lot of examples in the documentation about how to do this with Spring, for example. Or if someone is interested, I can show you like the example code after the talk. All right, I will just like start again, and then in the terminal we can say like watch Docker or Docker ls Docker container ls. All right. So here we see also like what's happening. We are having, there's also the old database still running. Docker container, which one? ADD, okay. I run it again. And like, it's sufficiently quick, you see, yeah? So for these 3 tests, we are like basically starting a complete database from scratch, applying the basic schema, running the test, tearing it down, yeah, and it's like 5 seconds. It's not perfect, it's slower than unit test, but it's quite okay, I would say. And sometimes you want this extra confidence to test against the real thing, yeah? And, oh, it was so fast I couldn't run the Docker container as here, because I wanted to show you something. So, yeah. So what is happening here? You see the Postgres image, the Postgres container is starting as we would expect, but an additional test containers, specific container is also starting here. And what this is doing, this Rio container, it's a sidecar container that's spawned by test containers, and it's just there to ensure that after JVM exit, all the resources that have been created by test containers are cleaned up. Like all containers removed, volumes removed, Docker networks removed, whatsoever. Like this used to be just a daemon process in the JVM, spawned by test containers, but the shutdown hooks that was registered would not get called if you kill the JVM running the tests. And this would normally happen if you cancel a build in CI, for example. Often the build runner will then basically kill the JVM. So we thought it might be a better idea to get this functionality out of the JVM into its own container, and this works very good. So the JVM is sending heartbeats to the sidecar container, and once the heartbeat stops, it just kills all the stuff that has been created. All right. So yeah, there is a lot of other stuff I could show, but since we're like running a little bit out of time, I want to go a bit further to show you another very cool example, and this will use Docker Compose here. So we will use Docker Compose to spin up kind of an application consisting of multiple microservices. This example we are looking at now will be the example voting app from DockerCon some years ago. And the cool thing also, it consists of many different technologies, not only Java. So we have a Python front end, Node.js front end. We even have a .NET stuff in the back end. And we can still use test containers in Java to black box test this context of our microservices. Yeah, okay, this is what the Docker Compose would look like. Not too interesting. This is also not something I will go into detail, but basically what I will show in the demo now is a Selenium test of this Docker Compose, like described service system, and we will use JEP as a Selenium abstraction to run the test, to instrument the browser. And yeah. All right, So now this demo we are running in the Oracle Cloud now, fittingly, and so this is like just a server in the Oracle Cloud, a virtual machine basically, just a simple Ubuntu image there, and it's also like completely headless. And I have nothing installed there, just Docker and Java, I think. And we now want to run the tests here. Let's quickly look into the code. All right. So we have here a Docker Compose file I was just talking about that describes those different services. And this can be just used by test containers via the Docker Compose container. You can then specify this Docker Compose file. And here we see another special test containers module. It's a browser WebDriver container. It's a container already containing a browser and a Selenium WebDriver. And then you can easily drive this browser. Now what we're doing is we're like having some setup stuff here. I will not go into detail here, but we're basically putting the Selenium into the same Docker network as all those Compose services, meaning the Selenium now can access those services using their container name, like basically the Docker DNS here. And like what the test is doing, it's visiting first the vote page. It's one front end, then it checks like, okay, in the beginning, like it has two buttons, and we go to the result page. In the beginning, it shows 50-50%. Then we go again to the vote page. We vote for one thing, and then we go to the result page and check that it has been 100%. All right, and I'm going to run this now here. So now we see Docker is starting, test containers is booting up all those services, creating the networks, creating the services. So now it's starting Chrome. It says there somewhere standalone Chrome. So it's now starting the browser. Everything running like completely headless here. And now a cool thing starts, like a VNC recorder sidecar container is started. That's something that's included in this browser WebDriver container from Testcontainers, and it will automatically make a video recording of the test. Okay, and test is done, and it was successful. Yeah, all cool. So now what we have, if we look into the results, where's it built? Test results. So now we have here, like I run this test a couple of times already, but basically we now have a video recording here from, like this is like the most recent one. And let's check this video recording out. All right. So this is just an alias to spin up a Docker container that will serve this directory, so I can easily download these files from here. All right, and this is a test file. Let's just download it. Let's hope it works. Yeah, this looks good. All right, yeah, works. And you can like easily just check this in, and it will work for every developer. It will work the same way in your CI. You don't have to manage some Selenium cluster or whatever. Yeah, so I can very much recommend it. We did it ourselves in projects, in different projects. All right. So yeah, let's skip those topics. Of course, you can also run everything inside containers. If your CI is already running in a container, then you just have to know what you're doing. Like you can use Docker in Docker or Docker socket mounting, whatever. Like it's all solvable. And yeah, there is some future for test containers, but it's like basically production ready. We have many users, and it's a very stable version, 1.10 now, I think. We have some things we think about in the future. There are also some forks in other languages that don't really share code but share concepts, like we have implementations for Go, for Rust, JavaScript, .NET, and so on and so on. Support for Windows containers is something we're still looking into, but since we're all more Linux guys, there is no one that really pushes this agenda, I think. And yeah, like it's an open source project, so if someone is interested also working or contributing, we are very happy to get more contributors, and also just to get feedback or issues if something isn't working. And yeah, here are like the links. I will tweet these probably. And yeah, this just to show like Java works very well in the Docker ecosystem and with all those Docker tooling, and it really works well if you combine them together with the right tools and the right approach. And yeah, thank you very much. We have some time left for questions, or also, of course, you can just come to me after the session and we can talk in detail. We can also talk about problems you are having in your projects, if they are maybe solvable with test containers. I have some test container stickers with me if you want. And yeah, thank you, and questions.